Properties of liquid oxygen. Attention! Oxygen is an oxidizer and promotes rapid combustion. Liquid nitrogen can cause frostbites. I don't take any responsibility for damage done to persons or property caused by the recreation of these experiments. For the preparation of oxygen, some manganese dioxide was added to a round bottom flask. A pressure equalizing dripping funnel was placed on top, which was filled with 30% hydrogen peroxide, but 3 to 10% would have been better. At the beginning, the apparatus was left open. Then the peroxide was added slowly to the manganese dioxide. The manganese dioxide catalyzes the decomposition of the hydrogen peroxide, and water and oxygen are formed. The high concentration of the peroxide caused a part of the water to be evaporated due to the heat of the reaction. To allow the air in the apparatus to be replaced by the oxygen, a balloon to collect the oxygen was added only after a short while. When enough oxygen had been collected, an isolating container was filled with liquid nitrogen. Usually a dewar flask is used for this, but to make things more visible, a beaker was put into another instead. The balloon was placed on top of a test tube which had been poked through a styrofoam plate. The plate isolates and keeps the test tube in place. The nitrogen boils at -196°C, while oxygen has its boiling point at -183°C. This causes the oxygen to condensate in the tube. To remove ice from the surface of the beakers, it was covered with some ethanol. Liquid oxygen has a pale blue color, which can be seen better when the prepared oxygen is dried before the condensation, as it can be seen here. In the meantime, 2 strong neodymium magnets were also cooled with the liquid nitrogen. Then the oxygen was poured onto the magnets. The oxygen is obviously attracted by the magnet, which can be explained with the molecular orbital theory. For the oxygen, the diagram looks like this. To the left and right are the atomic orbitals of the 2 oxygen atoms, which can be used to form molecular orbitals. Both of the s orbitals of the oxygen atoms provide 2 electrons each, so the bonding and anti-bonding orbitals are filled with electrons, leading to no bond. This is why the p orbitals are more interesting. The bonding sigma orbital has 2 electrons, while the anti-bonding orbital is empty, so a sigma bond is present. The bonding pi orbitals are occupied, which would lead to a second and even a third pi bond, but in the anti-bonding orbitals are 2 unpaired electrons. These are the reason why oxygen is paramagnetic and attracted to a magnet. This also means that oxygen doesn't have a second bond in reality, but 2 unpaired electrons. That's why oxygen is a diradical and quite reactive. As a comparison, the simplified diagram of nitrogen is shown, which has no electrons in the anti-bonding pi orbitals, so it is diamagnetic and thus not attracted to a magnet, or more precisely slightly repelled. The reactivity of oxygen can be shown by reacting it with cotton wool. These were a few properties of liquid oxygen. I hope you enjoyed. Please rate and comment. For more reactions with liquid gases or highly reactive chemicals, I'd recommend you to take a look at the channel Chemical Force. I'm subscribed to it for quite a while now and was often amazed. Here you can see a lot of videos about compounds that most chemists only have read about. And there is a large amount of reactions many wouldn't even dare to try out. So if you're interested in the reactions and properties of exotic, expensive or highly reactive compounds, take a look at Chemical Force. Links are in the video description or in the end card. If you want to see another method of preparing oxygen, you can watch my video here, or you can watch my latest video here. The channel Chemical Force can be reached here. A big thanks to my supporters on Patreon.